Yep, after that we can go. Hi there, folks. Okay, quickly, we're going to just review adding, subtracting fractions and mixed numbers, and then multiplying whole numbers by fractions. Um, this is our last unit. I put up a review quiz, and some of you aren't happy with your mark. I'll put up another one for you to try and improve your mark. Um, but please review first before we actually go and try another quiz. Okay, so uh, ideally this is done in class, but here we are online, and so let's go. Adding fractions, so you're going to be needing to think about whether our denominators are the same. Okay, if they're not the same, they're not common, we need to find common denominators. Okay, we find equivalent fractions by thinking about, what the denominator is going to become and multiplying the numerator by the same number that we multiplied the denominator by. That will create an equivalent fraction. Then once the denominators are equal, are the same, then we can start adding or subtracting. Okay, so let's look at 1/2 and 1/3. 1/2 and 1/3. 2 and 3 are not the same number. We need them to be the same number. How do we make them the same number? We find a multiple. Okay, we find a multiple of 2 and 3 and think about what the first one is. If we were starting skip counting by 2's, 2, 4, 6, skip counting by 3's, 3, 6, we find that 6 is common between the two. So that's how we're finding common denominators. So 6 needs to be the denominator. Okay, now these equivalent fractions, 1/2 becomes something out of 6. How does that happen? Let's think. How does 2 become 6? We multiplied by 3. We need to multiply the numerator by 3 as well, because that's what has happened to the denominator. 1 times 3, that's 3/6 now. So 3/6 is equivalent to 1/2. What happened over here? 3 became 6 when I multiplied by 2. So I multiply the 1 by 2 as well, and that becomes 2. So 2/6 is equivalent to 1/3, 3/6 is equivalent to 1/2, but now we have common denominators and we can add. 3 plus 2 is 5 out of 6. Okay, that's our final answer. Now we ask ourselves, can we reduce? We're looking to find a factor that goes into both 6 and 5, and we don't see that, because if you think about the numbers that can go into 6, 2 can go in, right? Can't go into 5. 3 can go in, can't go into 5. And 1 and 6 are the other factors of 6. And of course 1 goes into 5 as well, but if I divide it by 1, we wouldn't reduce our fraction. It'll still be 5/6. We can't divide by 6 because actually 6 is not a factor of 5. So this is lowest terms. Okay, so this is the key. We're always looking to find lowest terms or simplest form. Okay, you're going to find on that quiz it says I like represent your numbers in simplest form or lowest terms. That's important. Let's look at 3/5 plus 2/10. Okay, sometimes we don't need to change both fractions. If one of the denominators is a multiple of the other, like 10 is a multiple of 5, right? 2 5s are 10. We don't need to change them both. If we can see how by skip counting by 5s we can get to 10, whoops, over here, we don't need to change both. We can turn this into a fraction out of 10. We already have this one as a fraction out of 10. So 3/5 becomes, times 2, 6/10. 3/5 and 6/10 are equivalent. All right. Now, what do we do from there? Well, we add, of course. We add 6 plus 2. That's 8/10. Okay, now here we do have an opportunity to reduce. Right? We have the numbers 8 and 10. Is there a factor that you can divide both 8 and 10 by? I hope you're thinking about the number 2, because both these guys are even, they are divisible by 2. So if I divided both by 2, divided by 2, divided by 2, I would end up with 4/5. That's lowest terms for 8/10. Okay? So that's how we think about our last step. We get our sum or our difference, and we then decide if we can reduce. Whatever the biggest number is that you can divide out of both 8 and 10, That's the one you use. Okay, moving on. Let's see what else I got down here. I have another addition which we're not going to go through. We'll talk about mixed numbers. I won't deal with the 2.5 and 3.5, but I'll deal with the one below it because those are different denominators again. All right, we got a 3 and a 4. Now, again, we can think about this in a couple of ways, right? We can separate the 3 and 2/3 into whole number and part of a number, like the fraction part, or we can change these into improper fractions, and that's what I want to try and do, because eventually this is where we're going, right? When we start multiplying and dividing next year, we need to be able to convert into improper fractions. You need to do it anyway this year, but you need to do it with a purpose next year. So let's think about 3 and 2/3 as an improper fraction. I have, if my denominator is 3, which you can see, then everything's cut into 3, right? I have uh, 3 whole groups of 3. This whole number means 3 whole groups of 3. That would be 9/3. Think about it. 9 divided by 3 is 3. So that's how, for the improper fraction, it represents 3 wholes. Plus, I have 2/3 more, right? So altogether, I have 9/3 plus 2/3, which is 11/3. 11/3 is 3 and 2/3 as an improper fraction. Okay, then we do the same to the 2 and 3/4. This one's cut into fourths. 2 whole groups of 4 are 8. 8/4 represents the number 2, right? 8 divided by 4 is 2. Plus the 3/4 more, so that's 11/4. Okay, so 11/4 is the same thing as 2 and 3/4. All right, good. Now we're at 11/3 plus 11/4. We don't have the mixed number, we don't have the whole number component to deal with anymore, so we're good to go. But we don't have common denominators, so we're not quite good to go yet, but we're going to get there. What's a multiple of 3 and 4? 12. Hopefully you're thinking 12, right? How does 3 become 12? This is just a procedure. Every time we try and convert into an equivalent form of the fraction, we have to think, how did denominators change? How did it change? We multiplied that one by 4. So 11 times 4 for the numerator, 44. Come over here. How does 4 become 12? Times 3. 11 times 3. So our numerator becomes also affected by the same multiple. It got 3 times larger as did the denominator. So we have 44/12 plus 33/12. Now we can add. Luckily, we have common denominators. 44 and 33 is 77. So we have 77/12. Okay. Now the last thing is put this back into mixed, because we don't usually we don't leave numbers in improper form. But putting it back into mixed, we're thinking about, remember, fractions are division. We've said that so many times. Fractions are division. So 77 divided by 12, or how many 12s are there in 77? If we think about it, 12 times 5 is 60, 12 times 6 is 72, 12 times 7 is 84. That's too much. So 12 times 6 is what we're thinking about. So this is 6 whole groups for sure. And what did we say? 6 times 12 is 72. How would I get to 77, which is the numerator? What else? I would have to add 5. Therefore, the numerator of the fraction is 5. Okay, so 6 and 5/12. The denominator is still 12. And there's our mixed number. Okay? All right. Moving on. Subtracting fractions, same deal. It's the same thing as you did with adding. Look at the denominator, see if they're the same. If not, make them the same by creating equivalent fractions with the same denominator. Let's look at 3/2 minus 9/7. All right, so 3/2 minus 9/7. I don't have a common denominator. 2 and 7 are not common. What are the common multiples of 2 and 7? I think you're thinking 14, hopefully. I'm going to change both of these guys into 14s. How did 2 change into 14? I multiplied by 7. So I got to multiply my 3 by 7. 21. How did 7 become 14? I doubled it. So I double 9. Double 9, 18. So now I'm looking at 21/14 minus 18/14. They're common denominators of 14, which is great. 21 minus 18 is 3. That is lowest terms. You can't bring that any lower. Okay? Now, thinking about um, subtraction. I'm going to just put this one up there. You can scroll through this. It kind of explains my thinking, but then I'm going to show you a question that we do together as well. Okay, so you can look back through there, see the thinking, and then see what we had to do to end up with 2 and 11/20. And now we'll do the question below. 4 and a sixth minus 1 and 2/9. I would definitely go into improper fractions here. Okay, you don't have to all the time, but it's certainly more universal. 4 and a sixth. I have 4 whole groups of 6. 4 whole groups of 6 are 24 sixths. 24 sixths plus the 1/6 more. Okay, that's what a mixed number is. It's 4 and a sixth. So we are adding the sixth in. Okay, that's going to be 25 sixths. So 25 sixths is the improper fraction that goes along with 4 and a sixth. Subtract one whole group of 9 is 9/9. Sorry, yep, 9/9, right? That's 1 plus 2/9 more. That's 11/9. So I got 25 sixths minus 11/9. Now I don't have a common denominator, 6 and 9, and we have to work on our multiples, right? What does 6 become? What does 9 become? What's the first number they both can become when we multiply? The skip count, 6, 12, 18, 9, 18. Oh, did you hear 18? Good, it's 18. We got to think about our multiples, and that's where we need practice, some of us, right? Okay, how does 6 become 18? I tripled it. So I triple the numerator. 25 times 3, 75. How did 9 become 18? I doubled it. So I got to double the numerator. 22. Now I have common denominators. Lucky for us. We can subtract 75 minus 22, 53. 53/18 is our improper fraction. Now our last step, back into mixed. I know I'm going fast. You can slow this down, of course, and rewind and go as slowly as you like. 53/18. How many 18s in 53? Well, there we go. 18 plus another 18. What's that? 36. Okay, so we know at least there's 2. Plus another 18. What's that? 6 and 8 is 14. There's 54. Ah, look, I'm a little bit too big. So there's not 3 whole groups of 18 and 53, but there's close. 2 and almost 1/3. Let's think. Oh, sorry, not 1/3. Almost one more group. So it's 2 whole groups, which would be 36. And to find out the difference, right? What's left over? I take my 53 and I subtract my 36, and I get 17. So that should make sense. It was really close to being a third group. So 2 and 17/18. Okay? All right. Moving on. Multiplying. Multiplying whole numbers by a fraction. Okay, I want you to think about repeated addition, and then we're going to make a connection here because it's really not hard. 3 whole groups of 2/5, for instance. 3 2/5 means 2/5 plus 2/5 plus 2/5. There's 3 of them. You can see there's 3. They all have common denominators. So when we think about multiplication as repeated addition, we can just add 6/5. That's what it is. Now the connection I want you to see there, 6/5, we would now go back into mixed, right? But I want you to look at the 6/5, for instance, to begin with. See how that connects with our multiplication. It's 6/5. So let's think about 3 times 2, right? The whole number 3 times 2 is 6. The denominator stays as a 5. I've told you this before. You can think of 3 as 3 over 1 if you want. And when we multiply fractions, we multiply numerators, 3 times 2. We multiply denominators, 1 times 5. That's why the 5 stays the same, because I'm kind of multiplying by that invisible 1. Okay? So that's what we would do there. I'll give you one more example. Let's use a mixed number. So let's say we got a 4.5 times 2. Okay? 4.5 times 2. Logically, you might be able to think of what the answer is. I know some of you kind of work that way, and I appreciate that. Your logical math brain working. But let's think about what we might do to show our work. 4.5 mixed number. I would like it to be improper. So 4 whole groups of 2, 8 halves. Plus 1 more half is 9 halves. I got to multiply that by 2, right? The whole number is 2 that I'm multiplying. So if we think about that as a mixed number, sorry, as a repeated addition, I got 9 halves plus another 9 halves, 18 halves, right? So if I multiply 2 by 9 halves, it's 18 halves. And now what really is that? 18 halves. Fractions are division. How many 2's in 18? 9. And some of you might have thought that through at the top logically. Logic would suggest that 2 4.5s is 9. I mean, I know that some of you are easily able to do that. But that's how I would show it. Okay? And that's it. That's a review. Adding, subtracting, proper, improper, mixed, multiplying by whole numbers. And after that, I want you to practice, and I'm going to tell you what to practice. Just give me a quick sec here. On the, hold on a second. On the Math Makes Sense, I'm going to write this down for you, okay? On the Math Makes Sense textbook that I hopefully you've all downloaded and everything's good to go, go to page 159, 160, do numbers 7, 8, 10, 13, 14, and 15. 15 says draw a picture for multiplying. I'm going to say don't worry about the picture. Okay? So that's going to be your review for fractions. If you're interested, if you were happy with your quiz, right, you did well, you probably don't need to go through all this stuff because you're kind of on board already. But if you need to, please do it, right? You are in control of your learning, so you make the best of this time. Find stuff to support, but hopefully this helped you as well. Okay? Have a great day, guys. We'll see you.